Hello and welcome to this presentation about validation of inputs. My name is Mr. O'Mara. I'm a VCE Computing teacher, and the intended audience for this is students studying either Year 11 Computing Units 1 and 2 or Year 12 Software Development students using Units 3 and 4. So let's start off with what the study design says. So the study design asks us to learn about validation techniques for data, including existence checking, type checking and range checking. And by the time we get to the end of this, you'll understand why we validate data and how we validate data. So, first of all, the question I would put to you if you're here in class is, what do we want to know when we are validating data that a user enters? So what's the purpose of this? What is it that we actually want to know? Well, we want the data from them, but we want to know basically, is it in the right format? Did they give us something, and is it something that we can use productively without causing any errors? So the next concept that I want to look at quickly before we get into the bulk of the presentation is the difference or similarities and differences between validation and verification. So I would ask you, how is verification different from validation? Well, let's say that I'm entering my customer number. So validation is, does it match the format that we're expecting for my customer number? We're expecting my customer number to be 6 digits long, no shorter, no longer, and we're expecting it all to be numbers without any punctuation. So we basically want to know, does it fit that format? Verification is actually looking up at the customer numbers and saying, not only does it exist, but does it match this person? So verification is about checking it against our records, whereas validation is just, is this in the right format? So why do we validate data that comes from the user? Well, one reason is security protection. One of the very real risks that we're worried about is SQL injection, where if you don't validate what gets put in by the user, that can actually be read as a set of instructions for the database, and it's actually surprisingly common, and it can be incredibly harmful. You can lose your whole database to an SQL injection. It gives us data integrity. If we've got the data that we want in the format that we want, then it's a lot easier to have information that we're going to use. Imagine if we asked you to say, how many pets you have, and some people typed a few and none of your business and 4 as a word and so forth, then you're going to have all of this data that you're going to have to clean up. So the GIGO is garbage in, garbage out. If you've got a system with really inconsistent data that you can't use, it's going to be a lot less powerful as a system. Robustness. Now that's one of the key terms from the study design. Robustness is how well it responds to errors. I also think of it as, does it respond gracefully? So what you don't want is some hapless user writing the word for and the program crashing. Or it just spitting them out of the workflow completely and saying, oh well, you didn't do what I expected, therefore we can't play. What you want is for people to have a graceful, continuous experience that's a bit forgiving of people making errors. With the user experience, you want to give them an opportunity to correct it when they haven't given you something in the right format or something that you can't verify. I actually had not a great experience of this. I was trying to get some cash out when I was shopping, and I think I tried to use my phone for verification, and you can't use that when you're getting cash out. So then I tapped my card, but I put the PIN in, and by this point either it was so bamboozled or I was, that it paid for my food but didn't give me the cash. Now, either way, it was a failure of process. It might have been my fault, it might have been its fault, but it actually doesn't matter much because it meant that I actually had to go and use somebody's time to get this situation resolved so I could get the cash that I needed. So user experience is important. And just business rules. You might have a thing saying you've got to be over 18 years of age to do this, so you want to check that it's in the right range. And finally, resource management. We want our program to be efficient. We want it to get the best result from the fewest amount of resources. So if somebody doesn't give you an input, don't go and check the range of nothing and with a data type of nothing, and don't go and look up if there's a customer with a customer number of nothing. Just stop them there and push them back and get what you need. So it's about being efficient with our resources. So the first thing that we check for is existence. Has the user provided any information at all? There are situations where we won't care, where it's optional information and maybe we'll let that go by. But I would remind you, particularly when you do your SAT projects, that you need evidence of all three of these checks. So you're going to need something where you do care. Even if it wouldn't sort of instinctively belong in your program, you've got to demonstrate this knowledge. So you're going to check, did they give you anything? You might check the input to see if it's talking mark together. You might check if it's null, which just means no value, or if it has a length of less than 1. Because if it has a length of 0, then it's nothing at all. So there are some of the ways. If the input doesn't exist, we won't waste resources doing any further checks. One of the things to keep in mind is that in a form in HTML there's a required tag, and that means that you can't submit it if the button is if the field is left empty. You would never risk your security on an HTML tag because they can be easily changed by a user, but as for the user interface and just layering your checks upon one another, and I'll show you later what I mean, I've got some double checks later on that I'll show you, that's a good starting point, but you certainly wouldn't want to use it as your finishing point. So here we have some Python code. We're collecting an input, there's the prompt, enter some text, and the user puts some input. It checks if not user input. What it's basically saying is if there's not a value in user input, then you're going to print no input provided. Else, which means there is an input, then you entered and you're going to feed back to them. So you'll see down the bottom, I didn't enter any input and it gave me an error message. Now, looking at this, I've actually improved on this code, and so what I would ask you to do is have a look at this and decide why is the code on the right-hand side better. And the reason that it's better is that on the left-hand side, if I get it wrong, it just gives me an error message, no input provided, and the program's over. I don't have a chance to use this program. It did handle the error, but it's effectively kicked me out without getting any further in the program. Putting it in a while loop and only breaking out if I get it correct, if you see down here, I put nothing, no input provided, ask me again, I type in hello there, and it says hello there. So that's what we're talking about in terms of robustness, that you want the user to be able to make a mistake and continue to use the program. The second thing that we're checking is the type. So we're confirming that the input is in the correct data type. There are a whole bunch of data types. Mostly we'd be talking about an integer, a float, a string. You could of course be checking for a character or a boolean. This is crucial for robustness. Computers care what sort of type of information they're given. They can do a certain amount of casting and flexible typing, but it's pretty important that we have it in the right format. And this is done in quite different ways in different languages, and it can require you to be a bit inventive. Python's actually really good for this, but I do a lot of web development, so Python isn't necessarily my go-to. So if we look here, I've collected an input. Now that input is natively collected as a string. Unless you specify what it is, the input command or keyword in Python says something's a string. So what I'm going to try to do is I'm going to try and cast it as an integer. So I'm creating user text as int, and I'm trying to turn what they gave me into an integer. Now, if that works, then I know that this is a completely numeric value, that it's an integer. So I am there, but if it fails, then that's actually what I want. And I say, thank you for entering a string. I actually just realised there's an error with this, in that I think in Python, if I were to give that a float, it would just round it to being an integer, so it would succeed in the try and say that is a number. But as I said, you have to be a bit inventive and you do have to do some testing. Now, the range. The range is basically what's the number about how long it is. Now that can mean two different things. If it's a string, you can check how long it is. So you might say, is it longer than 2 characters? Is it less than 100 characters? Very easy to do in every language I know of. Very easy to get the length of a string. If it's a number, you'd check the offered number is in the correct range. So if you're asking for their age, you don't want -17, for instance. You probably don't want 128 either, since I don't think anybody is reasonably that old. And in many systems, there is just a number, a limit on the size of numbers, and you can break your program by putting in a really big number. I think Python can handle numbers above the 64-bit limit, I'm not sure, but anyhow, it's a good idea to validate for range, and this is often a test for reasonableness. So let's have a quick check and see what you know. So there's 8 questions, and we're going to be answering true or false. Verification is defined as the checking of data for accuracy. That's true, it is. Confirming data against other sources is a valid method of verification. Yep, that's also true. Checking if a phone number fits the expected format is an example of verification. Well, actually, that's false. That's validation when you're talking about format. An existence check is used to ensure that a user has not left a mandatory field blank. Yeah, well, that's true. A range check would be appropriate to ensure that a user enters a month number between 1 and 12. Yeah, well, that would also be true. Type checking ensures that data entered into a field matches a required data type, such as ensuring a user enters numbers into a year of birth field rather than text. Yeah, well, that's true. Validation is generally performed after verification is complete. So that's absolutely false. You would validate your information first to make sure that it's in the right format before you would bother to verify is that actually true with what we've got. Does that match the records that we've already got? Checking if a password contains a mix of uppercase letters, lowercase letters and symbols is an example of checking for existence. No, that would be checking for type. And the primary difference between the two processes is that validation checks if the data is reasonable, while verification checks if the data is consistent and accurate and matches the source. Yeah, that's absolutely true. So hopefully you're a bit clearer about what validation and verification is. And that's it.